Okay, good morning. It is November the 10th, and blackboard's down. It's minus 24 degrees. But hey, you made it, and we're going to record this. I'm not sure how I'm going to upload it. We'll worry about that later, and it may only go in 15-minute chunks because I can't get into my subscription, but we got the free version. But we're going to do what we're going to do. Today we are starting with the heart, the cardiovascular system. I did actually wear my socks with ECGs on them, but you can't see them underneath my long underwear. So, oh well. Let's look at Anyway, this is what's going to go on today. It's going to be a makeshift kind of day. Let's first start with the functions of the cardio. Let's just go right to the heart parts. What I wanted you to do was to open this, and so let's look at what we did and how it went. Oh, some of you went a little.
Definitely or number 5.
Number 5. Yeah.
Number 5, group 5 is where it's at. Oh, group 2 looks good. What do we got? Group 3. There's no group 5.
I think we meant page 5.
Page 5, sorry.
Page 5, yeah.
Sorry.
You guys are really messing with me today. Okay, let's look at how it goes first, and then we'll start. First off, let's start with the chambers. The top and the fact that left is right and right is left. If you remember, when it comes to any diagram, you label it as if it's in the person. So left is right and right is left. So this is the right side of the person is blue, and the left side is the red. Blue means deoxygenated, red means oxygenated. So we start with the
right is red? Is that what you said?
This is the right side.
Right.
This is the left side.
Okay.
The right side is blue because it's deoxygenated. It's collecting blood from the body. Okay? And then it will send it to the lungs. Then in the lungs, it will come back from the lungs oxygenated. So then it will be red. We have no way to communicate with the online people.
You can type on the document and just say that the live or to record.
Can you do that for me?
Yeah, what should I say?
We're recording this on Screencast-O-Matic, blackboard's down.
Yes.
Go have a cup of tea or read your, or you could fake it. Yeah, there's no way to log in. There's no way to log in.
Maybe we should put it by the, maybe put it in 2 places.
Sure, put it wherever you think it works.
And then by the chapter 14.
Okay, top chambers are atrium, bottom chambers are ventricles. So let's start with that. Right atrium, very good. Right ventricle, very good.
I'm going to bold it.
Other side, right atrium, left atrium, left ventricle. Very good, we got those.
You get to see that.
Then we've got blood coming from, I wonder if we could, Google Meet. No, let's just go with what we're going with and hopefully record it. I'm probably getting a million emails here. I am. Collaborate outage. Oh, look at that. They send me an email saying Collaborate is out of. Sorry, I'm getting all these people freaking.
Am I in a narwhal? Yeah. Oh, that actually. There, she's really cute. I used to take care of a kiddo who took that where they have narwhals and belugas and all this stuff. So it's kind of like, it's cute.
Okay. Yeah, I figured she'd freak. Okay. I have a few. Did you write it on there? Because I've got a bunch of people doing the online isn't working. We good? You wrote something in there? Okay, let's continue on. So we have the left and the right. We have the blood vessels coming from the body and we have to put it in Latin. So they're veins because they go towards, but so it's called the vena cava. Inferior means below, superior means above. So we've got they're mixed up. So let's fix that. We've got superior means above, inferior means below. Good. So then we have the blood coming in. Now there are valves in between the atrium and the ventricle, and there's 3 different ways to name the valves just to make things confusing. Because they're between the atrium and the ventricle, they're called atrioventricular valves, and since this one's on the right side, it's the right atrioventricular valve. Since this one's on the left, it's the left atrioventricular valve. However, you go old school. Since this one has 3 flaps to it, it's called the tricuspid valve. Since this one has 2 flaps, it's called the bicuspid valve. Because the bicuspid valve looks like a crown, it's also called the mitral valve. Good. Now, the way to remember that, if you go to get shoes, you like to try them before you buy them. So when you pump blood through the heart, you like to try it before you buy it. Okay, so as it goes, the tricuspid comes before the bicuspid, but we also go by the name mitral, so that's just a way to mess with us. Okay, good. So we've got those valves. Then there's a second set of valves that go to what's called the great vessels. Anything going to the lung, it's got the word pulmonary on it. So the valve that goes to the pulmonary artery, it takes it away. Do we have so it's the pulmonary trunk, very good, pulmonary trunk. And then it's going to become the left pulmonary artery, very good. And the right pulmonary artery, because it's going to go here and go behind. That's good. Now, the valve that goes to the pulmonary artery is the pulmonary valve. Very good. You've got that right. So the blood comes in the superior vena cava or the inferior vena cava. It will come through the tricuspid valve into the ventricle. The ventricle will contract. It will go out to the pulmonary trunk, then to the left and right pulmonary arteries, and to the lungs where it gets oxygenated. When it comes back, it will come back from the vein. Anything going towards the heart is a vein. Don't worry about oxygen and deoxygenated, because here's an example, although you may have learned that if it's an artery, it's usually oxygenated. Here's an exception. The blood coming from the heart, from the artery, let's try that again. From the lungs to the heart is going towards the heart, so it's a vein, and since it's coming from the lungs, it is oxygenated. So the pulmonary vein is an example of an exception where it is oxygenated. So if it's coming from the right, it's the right pulmonary vein. If it's coming from the left lung, it's the left pulmonary vein. It then goes into the atrium where it's collected. It goes to the ventricle contracts, and then it is going to go through the valve going to the aorta, which is the main one here. So that's the aortic valve. Does that help, or was that really confusing? Both. Okay, a little thing to help you remember. I have no idea if we're going to get sound here, and I'm not even sure to move stuff. Okay, let's see if it works. Right? You probably can't hear that. Someone's messed with my sound.
He's got moves. It's the canned laughter that gets me.
That's really random.
I found the volume
That wants
button.
to come on and upset.
What a, sometimes
The
life's.
next one is gangsta.
You want to listen to the next one too? Well, oh, did you go away? What happened? I was still recording so nicely. There we go. Let's not mess with this. Okay. Sorry, I've got this wild collection of ends of cords here. Ah. Okay. We'll just go with it. So those are the parts of the heart. One more that I like to know, is this the one, or is this my favorite one? No, not this one. This one's the country version. I know. Oh yeah, there's all sorts of ones. That's the top one.
It's the circulatory.
The circulatory, oh, but we haven't taken the vessels yet. Whatever, it's just a cool song. While we're wasting time watching songs. Volume works now. Did you get that part? My favorite line of the whole song. Get a life.
And now the oxygen jump, but first we got to carbon dioxide waste to take on and into the vein and back to the heart again, and let the whole cycle start again. Taking blood from the heart to the cells and back, dealing with all things vascular and cardiac. Capillaries, arteries, and veins all the same, circulation is the name of the game. Taking blood from the heart to the cells and back, dealing with all things vascular and cardiac. Capillaries, arteries, and veins all the same, circulation is the name of the game. Taking blood from the heart to the cells and back, dealing with all things vascular and cardiac. Yay, yay.
Stop those notes.
I know.
Isn't that cool?
Christian songs for children now?
What the heck? I don't know.
Yeah.
That was cool.
That's very interesting.
Yeah. He does children's version.
Really?
Okay. So that was just a way to remember all the parts because you need to know all the parts. Now, when we look at the circulation, oh, look at that. They sent me a message. Blackboard is down. We'll let you know when it's up again. That's funny. Blackboard Collaborate is out. Too funny. Okay. Now let's look at the parts. Sorry, the circulatory. I'm all over the place here. Let's get back to some organization because I need. Oh, all my links are gone. It's okay. We can do this. We can do this. We have a link somewhere here, and we will use it, and we'll be fine. We're recording on a different program. She will publish later. Okay, I like that. Go have tea. Go have tea. There we go. Now I've got my black. Who knew that I would need to do this? There we go. There we go. Let's look at why we need a circulatory system. Or guess, why do you think we need a circulatory system? Okay, we gotta watch because we might time out at 15 minutes. No, we're not. So I am actually in my own private one. Cool. Now I'm talking to myself and you think I'm losing it. Oh well. What is the cardiovascular system? There we go. The cardiovascular system, or the circulatory system, is the main transport. So why do we need one? We need to transport. We need to transport waste. We need to transport oxygen and gases. We need to, I know it's here somewhere. Whoa, it's hard on the eyes. The function of the cardiovascular system includes transport, picking up waste, components of the blood. We're going to talk about that. All the important stuff will come up later. It's not being organized today. And part of me, only part of me cares. Okay, let's just go with the notes and then we can follow along. When we look at the circulatory system, quite often it's put here as the part that goes to the head, the part that goes to the lungs, the part that goes to the body. I want you to be aware of all these parts, but we're not going to label them right now, other than the part that goes to the lungs is the pulmonary system. So that's on page 2. No, right here. Label the components. So I want you to realize we have the pulmonary system. And the pulmonary system basically goes to the heart, and then we have the systemic system. And the systemic system goes to the body. So when we look at it, pulmonary is the loops that go to the heart. Systemic system are the loops that go to the body. Don't worry about the other parts. I just really like this diagram because it shows all the loops and how everything is all looped together. And circulatory system, you have about 5 liters of blood, which really isn't that much blood if you think a big milk jug is 4 liters. So you have like a big milk jug and a little milk jug of blood that just keeps going around and around. Good. The collecting chambers are called the aorta. The pumping chambers are called the ventricles. Then we looked at the valves. The valves prevent backflow, making one-way flow more effective. And that's really important. The whole idea of the heart is to pump effectively, get the blood in, get the blood out effectively. Name the valves between the atrium and the ventricles, and then name the great valves. So if we go back to our valves, just a second, I need to see this. Oh, this one's good because it's got, so let's look at our valves.
The heart is a muscle about the size of your fist. It lies behind and to the left of your breastbone or sternum. The purpose of the heart is to pump blood through blood vessels, arteries, and veins to all parts of your body. The inside of the heart is divided into 4 chambers. The top 2 chambers are called the atria and are collection chambers for blood. The bottom 2 chambers are called the ventricles and receive the blood from the atria and pump it to the lungs and the body. The chambers are separated by valves, which control the direction of blood flow. There are 4 valves: tricuspid, pulmonic, mitral, and aortic. Circulation begins at the right side of the heart, where blood from the body comes to the right atrium. This blood passes to the right ventricle, where it is pumped to the lungs to receive oxygen. Once it receives oxygen, it flows to the left atrium, and then to the left ventricle, where it is pumped to the aorta and the rest of the body.
Okay, let's take a second and look at the valves. So the valves, although they just look like little flappies in a three-dimensional one, when you look at the detail, there are actually these cords that tie it down to the bottom to prevent it from backflow or from flopping backward. Just a second, Google Meets, Google Hangouts. I'm still trying to get the rest of the class in here. Something went wrong with that too? Okay, I just quit. Okay, so if we look at the valves, here's the valve here, here are the flaps that hold it. So the valve is actually a structure to prevent backflow. You okay? No, don't do that. Don't go crashing on me. Okay, we're not going to watch that anymore either. There's the valves. So we named our valves. Name the valves that enter the great vessels. So first off, the valves between the atrium and the ventricles are called atrioventricular valves. That is the general name for them. And then when you break it off, the right is called the tricuspid and the left is called bicuspid or mitral. Good. The name of the valves that enter the great vessel are the pulmonary vein goes into the pulmonary artery. Try that again. Pulmonary valve goes into the pulmonary artery, and then the other one is the aortic artery goes into has the aortic valve. Okay, I got to stop focusing on everyone else here and start focusing on you guys. Now, when the heart contracts, you get heart sounds. Heart sounds. So you have the heart is described in two sounds. They usually say lub-dub, and I don't even know what it is anymore, what I hear, because I've been told for the last how many years that it's lub-dub, so all I can hear is lub-dub. The lub is a stronger sound. The dub is a softer sound, and you can hear a soft sound and a hard sound. Okay, that's normal heartbeat. Now, normal heartbeat is due to the closing of the valves when the ventricles, or when there's contraction. So let's look back to we need a heart that's beating. There we go.
The heart is a muscle. The top two chambers.
Okay. When we look at the heart contraction, the strongest activity of the heart is the contracting of the ventricles.
And pump it to the lungs and the body. The chambers are separated by
If you can ignore the guys speaking, you can hear the heart sound coordinated with the heartbeat.
valves, which control the direction of blood flow. There are
When the ventricle contracts, and that's the strongest activity, to prevent the blood from going backwards. When the ventricle contracts, you want it to leave the heart and go out the great vessels. To prevent it from going backwards, the atrioventricular valves close. It is that contraction of the ventricle that causes the atrioventricular valves to close, and that's what causes the lub. So it's not like a banging gate. It's more like the fluid making noise, sort of like when you pull the plug on the bathtub, you get that sound, because fluid is making noise. When the heart contracts, the heart sound is due to the fluid making noise as the gates close. Sorry, as the valves close. And the valves are closing to prevent backflow. So the lub sound, the strongest sound, is due to the contraction of the ventricles. Then let's see if we can coordinate what's going on with the soft sound.
4 valves. Tricuspid, pulmonic.
Kind of. When the ventricles relax and the atrium contract, blood will go into the ventricles, but you don't want the blood to come backwards from the great vessels backwards. So that's when the classification of valves called semilunar, which is the aortic, and the pulmonary veins valves close. So the aortic and pulmonary valves will close, and that will result in the second sound. Okay, so valves have a one-way flow, valves, heart sounds. The strongest sound is the lub, and it's spelled differently. Sometimes it's spelled with a P. I don't know what this textbook spells it like. The strongest is the lub, which is associated, let's not use words, associated with ventricular contraction, which is the closing of the atrioventricular valves. Okay? That is the lub sound. The dub sound is softer, and it is the closing of the semilunar valves when the ventricle relaxes. Okay, and just a reminder that semilunar valves are the aortic and pulmonary valves. Okay, good. And we're still recording. Wonderful. Then we talked about the two circulations. The pulmonary circulation, as we showed in the diagram, goes to lungs to get oxygenated. And the systemic travels to the rest of the body. Okay? Good. Listen to the heart sound at the beginning of the chapter. What causes the sound? We just did that. Oh well, I'm out of order. The movement of the fluid as the valves close. Good. Describe the heart wall. When we look at the heart, see if I can open the right thing without shutting the other part down. When we look at the heart has 3 layers. Endo means inside, so the endocardium is the layer inside, and you want it to be smooth, and it is squamish epithelial tissues, if you remember way back to chapter 3 or 4. It is smooth endothelial cells. That's endocardium. Then you have the myocardium, and myo means muscle. So the myocardium is the muscle layer in the middle. Then the outside or around is peri. Peri means around, and it's the pericardium that is around the heart. Okay? Good.
It kind of goes with the rest of the layers that we've been learning, right? Like the perimycelium on the bones that was outside.
Ostium, but yes.
Yeah,
Peri
sorry.
means around.
And then,
Like think perimeter, you're going around something. Yeah, it's Latin.
okay.
So think of it's Latin or Greek, I don't know which one. Think of your word parts. That's a prefix if it's at the beginning. So peri means around. Periosteum goes around bones. Pericardium goes around your heart. The perimeter goes around your area of your rectangular square or whatever. Did you have Rob today?
No, we had him yesterday.
Good, because he'll never be able to do this.
He's also upstairs in a classroom that tends to work all the time.
I know, we're in that classroom next term. I'm very excited. Except during basketball, it's basketball season and the coaches mess it up.
No.
But whatever, I know how to work it. Okay, so those are our heart parts. Endo is inside, it's epithelium. Myo is middle, it's muscle layer. And cardiac muscle to be particular. If you remember, we talked about cardiac muscle. And the pericardium, what do you think the pericardium does and what do you think it's made out of? It's on the outside, so it's protective. So usually it's connective tissue of some sort. Good. Function of the coronary arteries. We won't get into all the detail of the coronary arteries, but what I want you to realize is, oh, that's cool, look at it go. I'm so fast. The coronary circulation. There are arteries on the outside of the heart, which of course we don't have a picture of right now because that would make too much sense. There are arteries on the outside of the heart. And those arteries on the outside of the heart are called the coronary circulation. And they feed the heart muscle itself. The heart cannot get the oxygen from inside the heart. It has to have specialized muscles. And this is where you get your heart attack from, because those coronary circulation vessels get plugged up. Okay? I just want you to know that there is a really good circulation in the heart. On the outside of the heart, we won't name all the vessels on the outside of the heart because they're not important and you'll forget them all anyway. We've already gone through the cycle through the heart. Now let's look how the heart contracts. The contraction is called systole and the relaxation is called diastole. Dia means through, so the heart needs to react in order for the blood to come back in so it can go through. Systole, diastole is just a fancy word of saying contraction and relaxation. Describe systole along with the action and the movement of the heart. So, systole is contraction, but unless we say atrial contraction, we always mean ventricle, because really the atrium are very thin and they only push the heart a little ways. The ventricles are the thicker parts that will pump the blood to the larger part of the body. So systole is ventricle contraction. So when the ventricles contract, blood is pushed out of the heart to go wherever it's supposed to go. If it's the right side, to lungs, and left side to body. And if you actually look at a diagram of the heart, the left side is, let's find my heart diagram before I mention this. So if you look here, the left side is a little stronger. And it's stronger because it's pumping it to the body. The right side, you're only pumping to the lungs, so it's not very strong. Do you have a question, or you're just...
No, I was just seeing blobfish and it made me laugh.
Yeah, I try not to laugh at all.
It's a distracting kind of thing.
But I think it's better to have those as opposed to the names.
Yeah.
And then in one of my class, I'm supposed to be do participation marks, and it's like, I don't care who's online. I don't care who shows up. Like, I care, but I don't care. I care that you show up, but if you don't care, there's only so much I can do. Okay, keep me on track here, you guys. Systole, contraction, ventricle contraction, blood leaves the heart. Diastole is the opposite. So diastole is ventricular relaxation. Now think, if the heart relaxes, what's going to happen? Blood fills the heart. Okay? And it will be refilling it. Diastole and systole. Sinus rhythm, pacemaker cells, and heart cycle. Okay, this is definition right out of the text.
May I ask a quick question? Are you going to want us to know the, where is it here, like, oh, right, never mind, you already said it.
That you need to know the tricuspid and the bicuspid?
The pulmonary and the aortic valves.
Yes, you need to know your valves.
Yeah.
You need to know what valves are opening and closing when the heart contracts, when the ventricles contract, and when the ventricles relax. And you also need to know what heart is associated with, what heart sound is associated with the closing of what vessels.
Okay.
Got it?
Yeah.
Good. Oh no, I have an online class at 11 that's completely online.
No.
It's okay, we can do this.
It'll be fine.
And if not, it's out of my control. Right? Right. Sinus rhythm is the contraction of the heart. So there we go. The normal rhythmic beating of the heart is called sinus rhythm. Can someone fill that in if you're typing? Oh no, my typers aren't here. They're not online. You guys are all my writers. What a gong show. There are pacemaker cells, and the pacemaker cells set the pace of the heartbeat. And they are found in a specialized set of tissue called the sinoatrial node. And the sinoatrial node is, if you look on this diagram, sinus is kind of a word for a chamber. So the sinoatrial node is way up here. It's abbreviated the SA node, sinoatrial node. Then the pacemaker, or the sinoatrial node, will get a signal which will start the heart contracting. And it will then move its impulse from the sinoatrial node to the atrioventricular node. Then from the atrioventricular node, the impulse will go on this yellow line, which you see here, to the atrioventricular bundle called the bundle of His. Then it will go to the base of the heart, go down the middle of the heart, and then go around the outside of the heart in the Purkinje fibers. Purkinje fibers. I don't know why everything else has a name, and then Mr. Purkinje gets fibers named after him. SA node, AV node, bundle of His, Purkinje fibers is the order that it works. So the contraction of the whole electrical cycle is called the cardiac cycle. And the cardiac cycle is basically one cycle of the heart. Okay? And you start with sinus rhythm, and it is influenced by the autonomic nervous system. But let's go here. So the sinus rhythm is a normal beating. It sets the heart pace, and this is found in the sinoatrial node, which we call the SA node just because, let's give it a big name so we can give an abbreviation. Good. A little video that goes through pretty much what I just talked about, but one more time. There we go. and it coordinates the activity along with making flashes so you can see it better.
Which pet wants to come on an adventure today?
Oh, a new
Take that
ad.
as a yes.
That's kind of exciting.
Conducting system of the heart. Confidence. The conducting system of the heart is made up of specialized cardiac muscle fibers and is responsible for initiation and conduction of cardiac impulse. The conducting system of the heart consists of the following 5 components: sinoatrial node, atrioventricular node, atrioventricular bundle, right and left branches of bundle of His, subendocardial Purkinje fibers.
Okay, first off, it's components because she can't pronounce it. And notice it's the SA node up at the top. The atrioventricular node is sort of between the atrium and the ventricles. Then you have the atrioventricular bundle. Then there's the bundle, then they go to bundle branches, then they go to Purkinje fibers.
Sinoatrial node. Sinoatrial node is also known as node of Keith-Black. It is a small horseshoe-shaped mass having specialized myocardial fibers situated in the wall of the right atrium in the upper part of sulcus terminalis, just below the opening of the superior vena cava. It is known as pacemaker of the heart because it generates impulses about 70 per minute and initiates the contraction of cardiac muscle, producing a heartbeat.
Okay, the SA node is where the heartbeat is initiated from. It's where the heartbeat is initiated from. So it is actually termed the pacemaker node because it controls the beat. It starts it and it controls the beat.
Atrioventricular node is also known as node of Tauera. It is smaller than the SA node and is located in the lower part of the atrial septum, just above the attachment of septal cusp of the tricuspid valve or opening of the coronary sinus. It conducts the cardiac impulse to the ventricle by the atrioventricular bundle.
Okay, so after the bundle starts in the SA node and then it goes to the AV node. And in the process, the atrium will contract at the top. Then the AV node will start the electrical signal through the ventricles.
The AV node is capable of generating impulses at a rate of about 60 per minute. The speed of conduction of cardiac impulse, which is about 0.11 seconds, provides sufficient time to the atria to empty their blood into the ventricle before ventricles start contracting. Atrioventricular bundle. It begins from the AV node, crosses the AV ring, and runs along the inferior part of the membranous part of the interventricular septum, where it divides into the left and right branches. Since the skeleton, which is a fibrous framework of the heart, separates the muscles of atria from the muscles of the ventricles, the bundle of His is the only means of conducting impulses from the atria to the ventricles.
Okay, the rest is just too technical. I don't even like that one, I don't think. I don't think I like that one, it's too technical. I like the pictures though, because it shows the nice thing in yellow. Really all I want you to know is the SA node starts it all, goes to the AV node, bundle, branches, Purkinje. That's all you need to know. Other than it starts in the SA node, and the SA node is where the pacemaker is. The AV node is what stimulates the ventricles to contract. And that's enough. Blood vessels. Okay, do we need a break before we go on for the bit? I think I need a break. I think I need a break. I'm just going to take a quick break, but we need a break, and then we will come back and we will look at the different types of blood vessels. Okay, blood vessels, part 2. We'll just start the blood vessels. Doing pretty good. Let's see how it goes. What I want you to realize is that blood vessels, here's a little histology. Just look at these two circles without even realizing what they are. Tell me the difference, or talk to the person beside you, or talk to yourself, And basically, what is the difference between the bottom one and the top one? Just take 2 seconds and talk to yourself, since most of you are spaced out. In your mind, give me at least 3 differences. And yes, the fact that one is a circle and one is squished is a difference. It doesn't have to be that profound. Okay, let's look at it. The top one is squished. It doesn't have nice structure. The bottom one has nice round structure, and part of that round structure has to do with this middle layer. Okay, if you can see, the inside layer has more, what's that called, convolutions, bumps, hills, where this one has less. It's pretty flat. They both have this kind of the same amount of the outer layer. This one's got a little more bubblies in it. This one's more smooth. Okay, that's what I wanted you to know. Now let's look at it in terms of the structure of it. That middle layer is muscle. So the artery has more muscle to it, which makes sense because it's under high pressure. So being under high pressure, you need to be thicker, just sort of like a high pressure needs a thicker hose. So the artery is a stronger vessel than the vein. If you look in the inside of the artery, it's kind of up and down there, or it can be, and that allows it for stretching. Because the artery is under higher pressure, it's got some stretch to it. And as the heart pumps, the artery will stretch a bit, and then the elasticity will kind of contract. This is why when you feel your pulse, you feel it in an artery because of the stretching of your the stretching of the artery due to the pulsing of the heart. If you look on the outside, there's a thicker dark ring, pink ring. That is is connective tissue. So the artery has a stronger connective tissue which holds it on. Again, higher pressure. The vein is a little looser here, the connective tissue. Okay? So if we go to the diagram, there are 3 layers, and in Latin, so external, middle, and internal, but we have to turn it into Latin, so it's externa, media, and interna. Don't worry about the Latin names of it, just realize there are 3 layers. The inner layer is an elastic membrane that's epithelial tissue. You want it nice and smooth. The middle layer is muscles, and you will see that the artery has more muscle than the vein. And the external layer is, there's a little more of it on the vein, and it's a little looser. Okay? So when we look at that, that has to do with the structure. Now, I'm going to show you this video also, and fill in again the structure and how the blood moves in it.
There are 3 main kinds of blood vessels: arteries, capillaries, and veins. Arteries are large blood vessels that carry blood from your heart to the rest of your body. This blood is rich in oxygen and nutrients. As arteries get farther away from the heart, they begin to branch and become smaller and smaller. The smallest branches are called capillaries. And this is where the oxygen in your blood is transferred to your tissues. In exchange, the wastes from your cells, including carbon dioxide, are transferred into the blood. Just beyond this area, the capillaries begin to merge together and eventually form larger vessels called...
Okay, let's look at that. Arteries, there's one mistake here. It said that it's always oxygenated, but there's an exception. Arteries technically carry blood away from the heart. That's all I want you to say about an artery. Carries blood away from the heart. But it's, we haven't talked about that yet.
The veins, which lead back to the heart. As the vessels carry deoxygenated blood back to the heart, waste products are routed to other organs, where they are removed for disposal. As the deoxygenated blood makes its way back through the heart and lungs, it picks up oxygen and nutrients. The heart then pumps the blood out through the arteries, and the cycle is repeated.
Okay, The artery carries blood away, and it is under pressure. It's under pressure from the heart, And because it's under pressure from the heart gives it a push. So it's very important. And because of that pressure, they have a thick muscle layer. They have an elastic inner membrane, so it can expand. Okay. Then we get to capillaries, and in capillaries they are a single cell thick. Very important because this is the area of transport, of exchange, that's a good word. Okay, and if you're too thick, you can't do anything. The arteries and the veins are just there to get everything to the place. Then how is the blood moved through the capillary? It slows down as the blood pressure drops. Okay? Good. Then a vein is thinner muscle layer, and very important, veins have valves. So if you look back up at this diagram here, you can't see it. Okay, veins have valves for one-way flow. And because of the low pressure, they're low pressure, so blood uses body muscles to help move blood. Through the veins. Okay? Good. And that's, no, we can do, let's just do vasoconstriction. What does constriction mean? Get smaller. So vasoconstriction is to contract the smooth muscle to decrease the diameter. Decrease the diameter. Now, if you think of a hose, if you squeeze the hose, what's going to happen to the pressure? It will increase pressure, but eventually decrease flow. Good. Vasodilation is the relaxation of the blood vessel, relaxation of muscles to relaxation of the muscle layer to make the vessel larger. That will drop the pressure. But since you now have a larger hose, will increase the flow. Good. Blood pressure. Blood pressure measures the pumping of the heart, and it's systolic over diastolic pressure. And I always remember that because it's sky over dirt, because I used to always mix those up. And in normal, or it's 120 over 80. However, it's usually 120 to 140 and 80 to 100 now as a range. And that is good enough for the vessels. If you have any questions on, when do I see you again? Monday. Tuesday, because today's Thursday. We can go through and do a quick review then. We have a test next weekend though, don't we?
Yeah.
Yeah. We're good for time, and if need be, I'll just cut a few things off at that. Oh, we have to do lymphatic and immune yet. We're still okay for time. Because all we got to do is blood, and so I'm a little behind, but nothing too serious. Before Monday's class, watch what's called the Magic Doctor which is a video that describes the immune system very easily, and it is family friendly. So it's called Watch. I'll send out an announcement once Blackboard's up and working. It's a family friendly comic, so you can watch it with your kids, and it's called The Magic Doctor, Your Magic Doctor. It's just a nice comic or cartoon to get you to get thinking about the immune system, because the immune system has a lot of really crazy parts to it. But if you watch the video first, it will give you the background, so that way all the crazy parts aren't crazy, because they're little guys walking through, and you'll see the macrophages beating things up, and helper T's have cell phones and stuff like that. Okay? Good. That's enough for today. That was an event. I probably have another 10 minutes here, but nothing too serious. So that's it.